So let's talk about operators and expressions. Okay, operators and expressions. Operators are symbols that allow you to do something with data or a value or a variable in Python. An expression is any time you put together a variable and at least one variable, at least one operator, you have an expression. So get used to those terms, operators and expressions. After we get through this little bit, that will make a whole lot more sense to you. By the way, you literally just saw me use an operator and an expression when I added 30 years to my age. So let's go through some of these. The most common is the assignment operator. It's the equal sign. When we say x equals 3, we're telling Python that the variable x is equal to 3. We've been using that, so the assignment operator shouldn't be too difficult to track. So in this case, x is equal to 3. That seems pretty obvious. Let's step it up a little notch here. We have addition, the addition operator. Now this is an expression that contains two operators, the assignment operator and the addition operator. So x is equal to the value that you get when you add 3 plus 1. What is x equal to? 4. Okay, so you're getting the hang of this already. In this case, what is x equal to? 2? Yeah, there we go. This is, bye-bye. This is the multiplication operator. I know it's not what you're used to seeing for multiplication.
6.
Yes, the answer is 6. That's correct. Math whiz over here. And so we're using the assignment operator and a multiplication operator. We cannot use x for multiplication, as in this times that, because x has a different job here. We can't use a period because periods have a different job. So this is the symbol that we use in computing for multiplication. Okay, so here's division. That is a forward slash. Many people struggle with the difference between a forward slash and a backslash. If you want to know my secret to remembering, a forward slash is leaning forward in the direction we read. We read left to right, going this direction, so it's leaning forward. It's a forward slash. If it's leaning the other direction, it's a backslash. So a forward slash is division. So x is equal to 9 divided by 3, or 3. And then we have one more, the exponent. Okay, so it's 2 asterisks together. And this reads x is equal to 2 to the power of 4. So in other words, 2 times 2 times 2 times 2, 16. Yeah, it's 4. If we do it 4, 2 times 2 times 2 times 2. Yeah, 16. But wait, there's more. Now we're getting a little bit weird here. These aren't normal math operations. The modulus operator is the percent sign. And although you may at first ask yourself, why on earth would I need this? You will find yourself using it a surprising amount of time. The modulus operator does division, so it divides 10 by 3, but it doesn't give you the answer to the division problem. It gives you the remainder, what's left after you divide 10 by 3. So if I divide 10 by 3, the answer would be 3 with a remainder of 1. It gives you the whole number, that's the remainder. So 3, it goes 3 times with 1 left over. So in this case, x becomes equal to 1. It just leaves the rest out. Floor division does the other part of the division and leaves out the remainder. So it does the division, and whatever the remainder is, it just gets rid of it. It would be 3. Yeah. Those are both really useful for understanding and identifying weird numbers. Let's say I have a problem where I need to know if the number 17 will go into the number 6,842 evenly. If I use modulus, if I say the big number divided by 17, I can't even remember what I just said because I made it up, and the answer is 0, then I know that that goes in evenly. If the answer is anything other than 0, then I know it doesn't. Floor division is really useful for dividing things into groups. If I have 20,732 and I want to divide them into equal groups of 6, I can use floor division and I find out how many go in each group. And then I can use modulus to find out how many are left over and distribute that between the groups. So there's a lot of like thinking and problem solving that you can do with those two operators. They're not super common, but when you need them, they're coming so handy. The increment operator takes whatever x is and puts 3 more in there, in this case. So x plus equals 3. We'll take this variable. It won't create a new variable. It will just say x. If your x is equal to 0, then after I do this, x is equal to 3. If I do it again, x is equal to 6. If I do it again, x is equal to 9. It's really handy for counting things or counting by multiples. So I can also use that same pattern with these other operators. So I can count backwards by multiples. I can divide, multiply, powers of, and floor division. The only thing you won't see there is modulus because it doesn't make sense to have a modulus increment operator because modulus only returns the remainder. So that's not going to be useful in any case because we wouldn't do that in a repetitive way. So another thing that's important when we're doing math, and you may experience this with assignment 3, is the order of operations. Order of operations tells us what order we do things in to get the correct answer. Some of you may have heard this word, PEMDAS. It's a way of remembering the correct order that we do things. So if I have an equation that looks like this, PEMDAS tells me what order to do things in, right? So parentheses first. So I've got 2 sets of parentheses here. I can do them first, right? We've got 5, and then we'll just take this 4 down, and then we're going to multiply times. Here's the other parentheses. I'm going to solve that next. Inside the parentheses, there's no more parentheses, so I go to exponents. 4 to the power of 5. 4 times 4 times 4 times 4 times 4, whatever. Yeah, that's too hard for me to solve. I'm going to say 4 to the power of 2 here. Cheating. Yeah, 16. So, and then we have a times 2, right? 32. And then plus 3 is 35. So we can say this is 35. And then plus 30 divided by 6. Okay, so now we're going to do multiplication division next. So 4 times 35 is, somebody help me out?
140.
We'll just call it 140. This is not a math class. 30 divided by 6 is 5. So the answer is 150, at least with the change that I made in that equation. It'd be much, much larger if that was the power of 5. But you get the idea. So that's how we need to know this, not because I'm turning this into a math class. The reason we need to know this is because Python is going to interpret formulas in that way. And so we need to know when we're setting up a formula to solve a problem in Python, how do we set it up properly so that Python knows how to do it and we get the right answer that we're expecting. So we can put it all in a line like this. But here are a couple of like cheat codes for you, okay? First thing, use parentheses to your advantage to control which calculations get done first. So in other words, if I put parentheses in here, inside, around the 3 and the 4, it would force that, because parentheses come first, force that to be calculated before this. I can force things to be calculated in different orders by using parentheses. I could do this to make sure that that gets done first. It would probably get done first anyway because it's multiplication, but I can use parentheses to my advantage. The other thing you can do, if you've got a complicated formula and it's just sort of frying your brain trying to figure out how to get it the right order, do the pieces on separate lines. So in other words, I could say x equals this, just this part, 3 plus 4 to the power 5 times 2. I could do that. And then I could take x and I could multiply it. I could put x in this formula in place of this part of the formula. So I can take the formula apart and do the parts of it separately and then combine it in the final step. And that oftentimes will make things a lot easier to just sort of wrap your mind around. I've gotten into lots and lots of situations where I've had to use both of those strategies just to simplify things so that my brain stopped hurting long enough for me to figure out the problem. Trust me, there's no problem there with doing that. So we can do all kinds of things, and you can print an expression. An expression is printable. Int floor divided by 3. So how many times does it go evenly? 22. What's the remainder? 1. So it goes 22 times with a remainder of 1. So you can do some simple math problems there. And so that helps you. You don't have to print things right away. I can do int answer equals int num, let's say to the power of 4, print int answer. So if I want to save the result of my calculation and do something with it later, I just put it into a variable and then I can do something with it later. I can do more calculations, I can save it, whatever I want to do. And I can even do this. Let's say plus equals 10 million. Okay. So all I'm doing is I'm taking this variable which is this to the power of 4. I'm printing it, and then I'm adding 10 million to it. And then I'm printing it again. Okay. So there's that. Now I can also do something like this equals okay, so now I'm taking that number. What you'll notice is here's an interesting thing that I'm doing. I have this on both sides of the equal sign. What is it that I'm doing? I'm basically saying, let's take whatever's in that variable, whatever number that is, take it out, divide it by 900, and then put it right back in that same bucket. That way I don't have to create another thing. This is kind of technically incorrect because anytime you divide two numbers, you always get a float. It's always a float. So the answer is going to be a float. So it's not technically correct, but it's not going to throw an error or anything. It's just I may be confused about it later, but floats and ints are very similar in what you can do with them. But there's my answer after doing that. So I take it out, divide it by 90, and put it back in there. Saying that's a strategy that I sometimes use if I don't want to create a new variable for each thing that I do. I just want to use the same container for each thing. I just self-assignment is what that's called. Yes. What's that? A type conversion? You mean like right here? You well, it is a float right now. Yeah, it's called an int. The variable name still says int. Honestly, if I was really concerned about being technically correct, I would create a new variable like that. Because look, if I say type, if I print the type rather than the actual number, that's a float. Even if I still have it labeled an int, you'll see it's still a float. Okay, so the type is not useful there. But I can do anything I want as long as my computer doesn't yell at me. Okay, so I convert it to a string. So I've got three nested functions here now. I'm taking int answer, I'm converting it to a string. That string I'm passing to the type function, which returns this, and then I'm printing it out.
So it's just printing string because that's the type.
Yep, because I just converted it right there inside that function. So if I don't convert it, if I get rid of that conversion, then it's going to go back to printing that it's a float, even though the variable name says it's an int. You got to be careful when you're doing conversions or you're doing things like this that you keep track of what your variable types are. But that's why the type function is so handy, because you can just use that to kind of debug your code and then get rid of it later once you understand what's going on. So lots of little useful tricks that you'll pick up on the way.